In this series, I'm going to coordinate an electrical system starting at the 600 volt level, this bus. I'll begin at the motor level, then move upstream to the motor breakers, here, and then coupler and both incomings, and later medium voltage protection. We have 13.8 kV at the upstream. Is a two networks, one of them networks of maximum short circuit, and each network has a maximum and minimum short circuit, and two transformers here comes to two buses, 13.8 kV coupler is between them, and after that transferred to 600 volt with two transformers, and we at the lowest level of the system. Protection coordination always start from lowest level of the systems. That means we start with the motors, then motor breakers, then couplers, and finally the incomers. Before touching any breaker or relay setting, we must first understand motor starting behavior, how to motor accelerate. This is the nameplate of the motors. 250 kilowatt and 293 amp. Here is a FLA, but this is a rated current. That the current is written on the nameplate. I prepare a sketch here. This sketch shows motor starting versus time. Here we have time, seconds, and here we have current. Motor started at here. At the moment the motor is energized, at this point, we see very high current spike called inrush current. The current can reach up to 10 times of the rated current, but lasts only a few short time, typically around 20 milliseconds. 20 milliseconds for inrush current. And then starting current can reach up 6 times of the rated current. Here we have I starting 6 times of I rated. It takes time 2.5 seconds for these motors. The settings here. The full load 2.5 seconds acceleration time. Let's back to our sketch. The LV motor is different. Some of them maybe 10 seconds acceleration time, and depend on the motors. After starting phase, and once the motor reaches the rated speed, the current drops. That's the drops of current. We go to the left and the current is drops, and the motor settles at the normal operating current. This is rated of the current of motors, 293 to 92 amp. Now let's look at this sketch. Here motor starting enters to breaker protection curves. What happens here? When the motor here is started, the operator pushed the start, the breaker immediately tripped, but not because of fault condition, because of the curve of the TCC, the curve of the breakers enters to the curves of the motors. That's why the breaker immediately trips. Trips immediately has two reasons. One is this concept, that breaker setting comes and intersect the TCC of motors, and second reason, it's a fault. Based on field experience, I've seen many cases where electricians assumed a short circuit occurred. In reality, the motor was simply entered to the starting region, and that's why the circuit breakers tripped. This is exactly what understanding motor starting behavior is critical before setting any protection. Let's see the correct one. This is curve of the circuit breaker. As you can see, does not intersect of TCC of motors, and this is the correct one. During protection coordination, the protective device curve must never cut through the motor starting curve. Otherwise, it trips. In the next video, we'll take to the next step and start discussing protection settings. The motor, as I mentioned, 250 kilowatt. As an example, I'll explain how motor breakers select according to NEC standard and how settings are selected and coordinated in details. Thank you for watching.